As stationary engineers, we spend our days in, on, around, and on top of commercial buildings, which got me to thinking, just how many commercial buildings are there in the US? Well, according to the US Energy Information Administration, there are 5.9 million of them. And one thing they all have in common is they consume tremendous amounts of energy. In fact, a study by the Department of Energy shows that commercial buildings consume almost 76% of all electricity and nearly 40% of the total energy produced in the United States. Now, it's because of numbers like these that our role as stationary engineer is so valuable. You might not realize it, but as engineers, one of our main duties is to mitigate as many expenses as possible for the building owners. And one way we can do that is by operating our buildings as efficiently as possible. As an assistant chief and lead green associate, one of my roles is to identify and implement energy conservation measures, or ECMs. Now, ECMs come in all sorts of varieties, but today we will look at just 3 of them, namely replacing light bulbs with energy efficient LEDs, installing occupancy sensors, and looking at ways that variable frequency drives can help us save money. By far, the largest consumer of electricity in the United States is commercial buildings, and there is no sign this trend will be slowing down anytime soon. Within buildings, there are 2 areas that not only consume the most energy, but are also great places to start when it comes to implementing ECMs. Building surveys conducted by the US Energy Information Administration show that HVAC systems in our buildings typically account for 39% of a building's total electrical load. And right behind HVAC is lighting at 25%. By making smart choices in these 2 areas, we can be sure to make an overall impact on a building's bottom line. ECMs don't need to be large capital improvement projects for them to be worthwhile either. By simply switching to more energy efficient light bulbs, you'd be surprised at the yearly savings you could realize. Just to give a quick example using real world numbers, I'll use my building as an example. We had almost exactly 5,372 light bulbs in our building, averaging 60 watts each. Yeah, I counted. By simply switching to energy efficient 9-watt LEDs, we reduced our electricity consumption for lighting by almost 85%, and we took our annual kilowatt hours from over 188,000 to just over 20,000. Also, by doing our research, we were able to secure a rebate for every single light bulb purchased, making the deal that much sweeter. After our light bulb project was complete, we also went ahead and installed nearly 100 occupancy sensors. A report published in the year 2000 by the EPA shows that we can reduce our electricity waste in those areas by as much as 68%. Now, those first 2 examples were low-hanging fruit that almost any building can undertake and see some sort of savings at the end of the year. But even after those were done, I wasn't satisfied. I started to look at the whole process as a game to see how much improvement we could actually make. I soon started digging through our commissioning reports and checking set points in our BAS. I began asking, why were they set the way they were set? Can we make any adjustments to them without affecting the operation of our building? Well, after a few weeks of digging and some hard work at the computer, I would soon have my answers. Typically during the design phase, building systems are designed oversized from the beginning to accommodate any future needs. Things like pumps and fans are sized up to account for future expansion or change in building's intended use. Now, after analyzing my building's data, I sat down at the computer and began working on the numbers. I was able to use basic formulas and simple math to compute exactly how my pumps and fans should be running to most efficiently operate in my building while maintaining comfort. It was during this time that I developed an interactive Excel worksheet where I could input the facts of my building and its multiple systems, apply some mathematical formulas, and I would have an almost exact number computed as to where I should establish my building set points. By manipulating different parameters on the spreadsheet, I could mimic making real-world adjustments to my building virtually, resulting in different outcomes for different scenarios. Where this exercise ultimately led me was to look at how my VFDs were operating. VFDs are incredible in that what appears to be a simple device is actually quite complex and can be manipulated in so many ways to our advantage. First, VFDs allow for a soft startup of motors rather than hitting them with line voltage right on startup, which ultimately puts a lot of strain on the motor's windings. By doing this, you are taking years of service life off a very expensive motor. A properly modulating VFD also minimizes wasted energy from oversized fans and motors, dialing in the speed to just satisfy the set points, rather than running full speed around the clock. However, it is in power consumption where VFDs can really shine. By a mathematical phenomenon known as the laws of affinity, a reduction in motor speed also realizes a nonlinear reduction in energy consumption. Now, to put it simply, if I use a VFD to operate my pumps, slowing them down just a bit means a huge reduction in electricity consumption. By utilizing a VFD and operating at anything less than 100%, I can see tremendous energy savings. Now, by working on the numbers on my building and utilizing the Excel worksheet, I was able to realize that we're operating our pumps at too high of a speed. By reducing my VFD speed down to 80%, my motors are now only using 51% of their horsepower, and they're still delivering enough water to satisfy my heating and cooling needs. Now, what all this means in actual numbers is pretty astounding. If I run my pumps at 100%, they cost me just under $14,000 each per year to run. By simply reducing them down to 80%, those same pumps now only cost me $7,000 per year, a nearly 50% reduction from simply slowing down the motors just a fraction. Over the life of 6 motors, I can expect to save almost $500,000, and I can extend their motor life with the reduced load. And the best part, it didn't cost a single penny to execute, and I could do it all from my office chair. Now, my chief had no idea I worked on all this for a few weeks by myself. When I had all the information locked and loaded, I took it to my chief, and then together we presented it to management. Needless to say, everyone from the top down was thrilled. In the end, all it took was a fresh set of eyes to take a step back, observe the situation in building as a complete system, and look for answers that might not be readily apparent. Now, ECMs can be as simple as a light bulb or as complex as a 150-line Excel sheet with dozens of equations, including square roots and exponents. But what matters is that we as engineers take the initiative to prove our value every single day. By thinking creatively and taking a holistic approach to what we do as engineers, our skills then become priceless.